And during my journey at Acquire, I used to build this, like forms, data entry forms, which I'm sure you're up to here building right now. And now this part of the journey is, well, combining both of those experiences and saying, well, we have the pictures, what can we do with them and the sensor data, right? And I think that way we should do them is to create a new way of logging, this visual way of logging, right? I think that's the journey into the future. And so it's the idea of combining these sensor data together with the AI to be able to log more effectively. But I realized something. So if this slide was in my PowerPoint, here to the right, there would be a database. And that database is, you could put a name to it. But the reality is that database exists because you treat the data in that database as like you're safe. You know, responsible for that data. She's QA, QCing. She's managing all that information from the lab. So this database still exists, and I'm not in any point in my conversation saying, let's replace Acquire right now. I'm just saying we will feed this data from this easier way of logging and managing your projects into that safe, right? And make your processes hopefully more effective. Any questions on that?
Yeah, so does this lead you can sort of feed the FastGeo logging into an already set up Acquire database, is what you're saying?
Yeah, that's exactly what we're building. So the journey starts here. I'm just gonna go into our dashboard, and our dashboard, we've kind of laid out the entire system on these menus: dashboard, drill holes, viewing, logging, 3D viewing, import, export, and settings. Our dashboard tells us the story of what's going on, what's the last thing that's been changed. We click on our hole here, and that actually is just linking to this viewing page. So in that viewing page, now what you're seeing is you're just seeing your imagery laid out and presented. And if I were to click on this here, what you're seeing is that some AI went in and it cropped the boxes. And some AI went in and it actually linearized the core. Some AI in there. Okay, that's kind of cool, you say. I hope you're saying that. And then I'm just going to click here and say, well, load this. And so now what I've done is I saved this view. And that view is based on all these parameters. I basically said, show me the lith code, show me the maxus, and bring that to screen. And so that's what I'm seeing here, right? So now if I click on my maxus, I'm beginning to see that that point is, 223.10 with a value of 0.43, and I see my values of my copper, and I see my logging, and I can begin to see the relationship of the logging to the sensor data. So this is where maybe you're seeing a big departure from other tools, is that now you have this way of presenting the data in combination. And then I imagine that in your mind, you're like, well, how did that data get in there, right, Fed? How does that data get in there? And the question I was asking myself is like, why do we have all these disparate sensors? Like you have a PXRF, as you just explained with the guys from GeoSab, right? Like you have a Maxus sensor, you probably have a structural orientation tool, and you have a spectrometer maybe. But everybody tells you, hey, these sensors are disconnected, export them, export the file, and import it into Acquire. And I believe that process is broken. I'm like, this is 2025. Why are we still doing that? So what we set out to do is say, well, these sensors are there. How do I integrate them into my workflow? So as I'm logging, I can create this view in real time. What I mean by integrating into my workflow is, well, here's a KT10. If you've used that device, you would see how much of a pain that is, because like you have to hit save. It's just crazy difficult. Yep. So what we built is different. Is basically you have that device, the device is connected to the PC, and you're not interacting with the PC. Basically, as I hit the next measurement, the next measurement gets saved and stored into the PC, and you'll see that the capture with this tool is probably 10 times or 5 times faster than you're currently doing, right? It's automated. And so you just do next. The data is clean, you can see it, and now it's in your repository. And from here, we can send it directly to Acquire, as we'll talk a little bit. But the idea was, well, like if we're doing that for one sensor, why can't we do it for more sensors? So here comes in the PXRF, where like, again, we have the PXRF. Why are we having to export that to a file to then take it in? And the idea is that you could connect, these devices do have a connectivity that we can use to connect. And so the idea is, why can't we just connect directly, get the data, auto increment, and manage that process? And the same way with structure, right? Like this is the next thing I'm working on is why can't I get the 3D structure of the core in a three-dimensional space and then measure the structure in 3D space?
Cool.
So the idea is we just want to take all this sensor data and collect it directly into the repository. So why? Why do I want to do that? Is because if I look at this picture, I can see that this Maxus could be telling me something that I wasn't seeing before. Is that everybody aligned, right? Like I know we don't use it for the purpose of logging, but I believe firmly that when we begin to see the signature, we'll begin to see patterns that we didn't see before. And the second reason I'm very interested in it, I'm sorry, go ahead.
No, I'll just agreeing, like, anything that you can sort of put side by side together like that just sort of starts building the picture pretty well, especially XRF.
That's a great interpretation tool. So, and just having it all there, like the way Imago used to align it like that, and then just having all your logs next to it is just, is fantastic.
And so kind of, I think you're seeing what we're trying to construct. And our objective is that why we love this sensor data is because sensor data is so much better for doing machine learning predictions. Because the imagery has a bunch of problems. Like, look at this line of glare. Maybe there was a little bit of contrast on the color. Like you have to control it very well for the imagery to be very homogeneous. The sensor data reduces that noise and it's more voluminous. So that's why we love, and that's why I'm so passionate about automating that sensor data, because it's going to be the pipeline for me to support the logging. So I actually didn't tell you initially, but if you kind of would ask me what it is that we're trying to do at FastGeo is three things. How do I make you log with less bias? So you see how I'm trying to reduce the bias by showing you the sensor data? How do I make you log faster? How do I get you to log faster with less resources? And maybe that's the next bit of the conversation, which is if I can support you with AI, I should be able to do that quicker. And the third thing is, how do I allow you to communicate the information of your activities more efficiently? So let's look at that second one, which is how do I get you to log faster? Well, if I take that image now and I present it in a logging pane like this, and then let's say these are my suites, we call them suites, you call them form definitions in Acquire, and I'm just going to select my form definition for lithology, for example. And I'm going to click a depth, then begin to see how that depth is depth referenced on the image. See, so 501. And so I can also begin to complement that with the lithology and the rock codes. So I can present the logging visually. So as I'm logging, I'm actually entering the data. But I can do that as well as I can also do the RQD and the recovery. So here's the RQD and here's the recovery, because the machine learning engine has processed that picture to give me these segments. Now, our philosophy with machine learning is a little bit different than everybody else. We don't believe that machine learning will be able to replace the geologist. We believe that the machine learning should be able to support the geologist in the tasks that they're doing. So that's why when you see these lines, what we're saying is these lines are the predictions, and this is a tape measure. And you can move the tape measure, and when you move the tape measure, the calculation itself changes. So it makes mistakes, right? Like the algorithm makes mistakes, but you have now the ability to change those mistakes by moving these lines. And so we're saying is we're hoping that we'll be able to augment you by supporting you, but it will be ultimately the decision of the geologist to say, this is what I want to log. So we're not allowing anything that is automated. The geologist must make and approve all data that goes into the system. And I think that's a clear distinction between what we're doing and maybe other of our, other people in the industry, right? Like we don't believe that AI will be able to replace what we do, but we do believe that it will be able to support us in making better decisions. So again, removing logging bias, logging quicker, and then communicating the logging more effectively. But if you didn't want to log in this way, and by the way, we can also support this by bringing in the sensor data. So here's our value of Maxus 5 with 0.7, so we can begin to introduce all this sensor data and bring it all together. But you can also do it on a grid-based basis. So this is your traditional acquire form of logging, right? Where you have your panel and your sheets and your selections. And this can be done both on the screen, but it can also be done on the mobile device. So everything that I'm showing you here is available on iOS, Android, and Windows. So you can log in this way as well. And then those calculations of the recovery and depths and all come in here. And then the third thing that I remember I said was, okay, logging less, reduce the bias, log quicker, and communicate your logging more effectively. So to communicate and to validate your logging, I mean, we're in a spatial science. Like the spatial context is so fundamental to what we do that being able to understand the relationship of this data together in 3D space is fundamental to our activities. But I don't understand why nobody has ever done this together. Like, we put it in isolation. Oh, this is the job of Leapfrog. No, it's actually the job of the logging geologist to be able to understand the context between the holes. It's not to interpret, it's just basically to make a better log and reduce bias, right? So that's why we also believe that 3D representation of the data or sectional representation of the data is very important. Now, you might say, well, we don't want to contaminate the geologist because we're going to introduce bias by them looking at the model. Then what we can do is turn on the 3D after they've logged, so they can't put a log, they can't put a log in the model unless they. What's your opinion on that, by the way? Do you guys believe that it's okay to see a 3D representation of the holes beside you, or you think that will contaminate the geologist's view of the model or the interpretation of what they're looking?
I personally think it's fine. I know a lot of geos disagree, but I think it's okay.
Really? Yeah.
Awesome. But because there's all both fields, what we're trying to do is make it dynamic so it can just meet your workflow. But I think that fundamentally, though, it's important to understand the context, and we built those tools. And so what you're seeing here, if I were going to summarize what I've shown you, what I've tried to show you, is this. I've tried to say, hey, we have all these tools to capture sensor data, be it the imagery, be it the XRF, be it the Maxus. We have all these tools to put the data and view it together. We have these tools to run machine learning models and create models to support you, and in particular, RQD and recovery initially, but you can do more things. We have these tools to log the data, and then we have these tools to connect the data, which was how you opened the conversation is, well, how do you connect this to acquire? And I really didn't show you this, but what I can show you is that we've built the entire architecture. I mean, philosophically, I believe that innovation is driven by interoperability. Like, this is a core belief that I've had in all my career, right? Like, the best way is to connect systems and give the customer ownership of their data in order to drive the product further. So I hate these ecosystems that, they close you out rather than connecting you. And so everything that I've shown you is driven by an API. And what that means is that programmatically, you can do whatever I've done here, you can do programmatically. Now, I'm starting out, like, I've only been building for a year, so it's not full. Like, I'm not showing you a full system, but I have a lot of the components in there to take you, I think, where you want to go. And we will get there as you transition, as you go in the journey with us, right? But I guess philosophically, that's how that's how we connect, is by having this open API. Possible, right? Like, we still can build these interoperabilities, and unfortunately, because the architecture is as it is, we need to build those interoperability connections for each case. So that's really what we build. That's what we're building, and it works for chips, and it works for Diamond. And then we're building some other really cool tools that I can talk for hours about, but I think this is the gist of it.